Manager of SYPAQ systems for major projects. He has over 20 years experience in engineering design and management, with the recent 10 years specifically within the Maritime Defence sector. He has 8 years experience as an executive engineering manager with demonstrated experience in project planning, definition and systems engineering execution. Martin is a discipline specialist in platform engineering, incorporating systems integration engineering, maritime and mechanical engineering, RAN analysis, safety cases, and risk and issue management. He is experienced in the successful delivery of complex engineering systems and services within technical regulatory frameworks within defence. Martin has worked in project management capacities as well as engineering management and has experienced the conflicts between project scope and technical requirements on both small and large work packages. So very qualified to present tonight on the value of integrating both project management and systems engineering. So I'll pass it over to Martin. Thank you.
Thank you. Assume everybody can hear me okay back there. Got the roving mic on. Let's bring up the slide. Right. So, how many project managers do we actually have here tonight? Raise your hand. A few. Have you all come from engineering, or is there any project manager that's followed a different path? Maybe one. So what you find is a lot of engineers do move into project management. There's very few project management that actually go and learn engineering, particularly systems engineering, and so you can start from that point to understand there's probably a knowledge gap there in the first instance. But the topic for tonight is about why do these domains that really need to work together to get a successful project have so much trouble working together. So let's step it through. I'm from a large element of my previous experience has been defence, and so a lot of the experience I've got is in the defence space. If you look at defence, is probably one of the ones that's really had systems engineering at heart forever. And yet they still fail to deliver. So the dark blue is what they originally said they were going to do, and the light blue is what they ended up doing across all their programs. This is last year. So the topic of only 30% of projects actually succeed, probably not far off the mark. So a couple of examples from defence that are recent: air warfare destroyers. Project managers on that would say they did a great project management job. But it was 3 years late and just lots and lots of problems, engineering changes galore. I was on the reform program that went across to actually try and work out why and give them some guidance on getting back on track. The MRH-90 helicopters, another classic example. Project management was actually really good on that program, but still the helicopters didn't meet capability. They're only just going into acceptance now. Haven't got final operational capability. And in the transport space, you've got the next generation, new generation rolling stock up in Queensland. Again, project management, great. Everything went really well, but they couldn't put the train on the track, and a vast number of deficiencies, 140 deficiencies, and of course political pressure to get cut-off games. All of that adds to the stress and pressure of trying to deliver a project. And the reason why I chose that one out of the raft of transport programs I could have chosen is the statement that the QTech manager at the time said, for all new training projects of this size and complexity, it's not uncommon to experience some delays and issues during testing, and they've rectified it accordingly 18 months later. And they had 2 baselines because of the issues that they had. This is the detailed design review. Everything was green, everything was great. Early start to system test, well ahead of schedule. Program management, the integration of the teams was absolutely perfect on this program. When they got them and they tested them, didn't deliver the capability, and they had a lot of work to recover. And of course, they're about to go to Cross River Rail, so we're hoping that they learn the lessons and they can apply the lessons going forward there. This project I expect to be successful because when you learn the hard yards and you roll over into a good project. So let's see how they go. So why is there such a problem? If you go to the classic, the optimist and the pessimist, or the one that's always been out there is the engineer who sees the glass as twice as big as what it needs to be. The project manager sees that glass as in scope. As in scope, you're going to get that glass whether you like it or not. You're not going to get a container, you're not going to get a bottle, you're getting a glass. So you get the right amount of liquid inside with the right quality there, you do it well. So systems engineering misconception, it's not just a process for complex systems. And I think the problem everybody has is they immediately go, oh, systems engineering is expensive and we've got to apply it to complex programs because that's what it's good at. Yes, it's good at that, but it's not just for that. And the mission that's always been around systems engineering for as long as it's existed is to realise solutions that meet stakeholders' expectations and cost, schedule, and risk. And of course, that's what project managers are trying to do. So again, trying to achieve the same outcomes, trying to achieve the same endpoint, they're just communicating differently and really struggling to work with each other to get there. So where we are present day, it's seen as a proven method for delivery of capability and complex systems. It's a structured, gated process. It's a classic V diagram that's always come with systems engineering, the gates you have to go through to achieve verification and acceptance. And the evolution of the standards, you know, the very high process driven coming out of military and out of software standards, down to our more generic standard of today. It's the more bread and butter standards applied to systems engineering, covers a vast array of the life cycle, much less process driven, and asks you to tailor and develop the process to suit your need. Asset management's the sort of new model on the block, and it relegates systems engineering down to one little piece of life cycle delivery. And the guys that developed asset management and the concepts around it came from systems engineering, so they knew what they were doing when they did this. They were saying people don't really understand systems engineering or what it's for, so let's just put it there where it's really known and good at, and we'll build the rest of the model around it. Systems engineering does everything that's on that page. If you look at our local, say, developing the misconception is still there around, it's around technical development, not around delivery of capability. Asset Management Council has their models or their views of how it all works in systems engineering again. It's just constrained to the bit that's about design and change, a little bit of support analysis thrown in there, but it's really the whole lot. Systems engineering drives operations and maintenance. So where did project management come from? Why are we in this situation we're in today? Project management sort of arose around the 60s, came out of when they got their algorithms to develop schedule tools, the critical path method and like processes. NASA picked it up, Defence picked it up, construction software, all those companies that were dealing with large programs trying to make them all coordinated work picked it up. We come across into the 70s, and project management starts to build this body of knowledge. So the case studies that were there were used to foster project management and move it forward. The society started to evolve, but really what drove its prominence here was the recession. So cost was critical after the 70s. You had to deliver your project on cost, and project managers were their work, their weight in gold. We get to the 80s, and now we've actually got tools. So Microsoft Project comes into play. Prince as a more structured model about how to deliver. PM comes in, and PMs are now getting certified as recognised practitioners of this methodology and approach. Into the 90s, and we're actually getting organisations restructuring around project management. So the old structures of organisations that were discipline based, and the engineering teams sort of ran a technical company. Now you've got project managers driving projects, and everything was focused on projects. So we start to see going through the 90s into the 2000s, functional matrices coming into play where you've got this continual fight with the project managers king, no systems engineer, or the engineering managers king. And so this whole organisation structure is coming into play. Finally, project management releases its ISO standard, and that's now trying to establish this is the way that the group should work as a bunch of like-minded individuals. Life cycles now are king, so project life cycles from start to finish, cradle to grave, all those terms get used in project management. And so the philosophies that exist around project management, Prince 2, it's again all about stages of the project delivery and the various aspects the project manager has to deal with. A bunch of processes in there and how to deliver that. PMBOK, body of knowledge that was originally just a series of use cases and best practice, evolved over time, and now in 2017, the last release, it really is a bunch of processes applied at the various gates of your project. It's a very process-driven standard now. And it's recognised as standard. It was recognised as standard in one of the earlier releases. It's now, people really do see it as a standard guiding the organisation for that domain. So where does systems engineering come from? Systems engineering is traced back to telecommunications when we first started having software trying to make decisions and I's and O's that you couldn't quite grasp. In 1960, around 1960 was when the first textbooks around how to teach it and how to apply it came into being. And of course in the 70s you see project management took off because it was about cost control and cost management. Systems engineering was really relegated to high tech and high complexity because nobody wanted to spend the money up front to use it. And so your defence, your IT, your space exploration, aerospace, they retained systems engineering in its core, but they developed their process specifically to their organisation, to their niche requirements, as it were. There was still elements of systems engineering in the other industries, automotive, but they tailored it really tightly so that it wasn't seen as systems engineering, so it wasn't seen as cost. Through the 80s, we get the engineering managers are the ones that are sort of managing and keeping this domain and discipline alive. Into the 90s, we get INCOSE formed, and INCOSE then starts to really embrace the systems engineering so that you've got a group that everybody can turn to go, what's the standard, what's the way we should be doing this. But they've come from that era of high complexity. So all of the standards and all of the work developed there really did perpetuate it's for technical domain, it's for the high complexity, it's in the engineering space. We go forward into 2000 and we see all of these systems and critical systems evolving because it's realised that a system is not just a system, it's complicated, it's interdependent, it's lots of dependencies. So systems engineering really comes into its own there because it understands that space and the interdependencies and interfaces. It's really good at that. But again, it's driving this wedge between project management groups that just want to get it done and the systems engineers over here that are just spending forever trying to work out how to do it. We get into 2010 and now we just have this perception of systems engineering and the philosophies are process paralysis. There's just too much process and everybody's following this process that costs us money. So when you look at project management and project management body of knowledge, this is from the body of knowledge version 5, the areas that project management deal with and cover are really broad ranging, and project managers look at these things quite linearly generally. They'll look at, I need to deliver a scope of work, break it all down, and then go, what resources do I need, and what stakeholders do I need to engage with. So systems engineering covers all of this as well. But systems engineering, if you apply it, you can actually dig through the layers and the interdependency between each of those areas and balance it for the right outcome, for the right risk profile, and get a much better outcome for what you're trying to achieve. So 2011, PMI, the project managers, INCOSE for the systems engineers, they get together and they say, we're noticing this big wedge, this big divide between the two domains. These guys really need to work together, what's going on, and they set up a series of surveys and studies to try and understand what's going on. Why can't these groups communicate and deliver successful projects? Most of the projects that they looked at came down to these groups just aren't talking to each other and in conflict. So when they did the analysis of, is it a fundamental, and they looked at it and went, what is project management trying to achieve in its standards and its scoping. And it was about life cycle, it was about staged gates, it was about delivering from start to finish. Come across the systems engineering, exactly the same thing. Concepts right through to retirement. The life cycle model and the life cycle principles are there. They're going, the two domains, the two disciplines are trying to achieve the same outcome, yet they're clashing with each other. And so they've dug into that. And they explored it in about 4 studies. So the first one, they went on to go out and ask some questions, got back a little bit of information, retailored their question. And the work they did in that really did highlight the problems that the two communities were having talking to each other and communicating. PM really focused on scope, delivery of scope, and whereas SE, in systems engineering, is around the requirements and was very technically focused on getting the right requirements and selling off requirements. ISO 21500, just for instance, because it was interesting, to search and the word requirements doesn't even show up. So project managers trying to deliver scope and forget there's a bunch of requirements that exist here. So that work resulted last year in a book, and many of you may have read it, pretty easy to get a hold of, and PMI and INCOSE, especially INCOSE, promulgated a lot because it's a very good text and does cover all those surveys that we've done and bring it down to boil it down to what's the principles here. And they came out with this unproductive tension concept. So really exploring why do these groups struggle so much to get together and sort it out. And the one problem though in this is that they eschew fixed organisational constructs. So they're looking at it here and now, going to have a project management organisation, you have a systems engineering organisation, and not actually looking at it as a holistic organisation where people are engaged to deliver the outcome of the solution. So all of these solutions in there are all about communicating and trying to learn each other's language, which is vitally important, but might not quite cover all of the topics. So when you actually get into it and you live this stuff for a while, what you find is it's very human nature centric. It's conditioned mind, it's conditioned ways of thinking, it's conditioning from where you come from, where you're going to. So if you come from a particular domain, you're conditioned to that domain. Definitely speaking a different language is a big element. So anybody that starts talking in acronyms and the other group will go, I don't understand what you're talking about, and they'll shut down. The systems engineers are shocking backwards. And so project managers will just go, that's your scope, you go away and deal with that. I don't want to know that's too hard. Don't understand you. Process compliance is also a big one for culture and resistance to change. Once you've got a process and you've lived that process for a while, you don't want to change from that process. You're used to it, you're familiar with it. And so you get big organisations especially really struggle with that momentum to change and move away from a process that may have worked in one project but it's not going to work in the next. The environment that you're in, so I've used rail standards here for the Transport Steering Committee, and rail standards really do fix people's minds around, we've got to do it according to the standard. But actually pulling back to go, is that standard actually applicable in this instance, or that clause of the standard, is that applicable? And then you've got societal, so business practices, contracting, how a contract's set up, how customers ask for it, customers mandating standards, but don't understand why they mandate them. Mandating processes, so you must comply with ISO 15288, but actually understand what that means. And then organisational, so org structures with role definitions. So this particular role does this thing in this organisation, and not every organisation is the same. We've all evolved, and most organisations are similar, but they're not the same. So moving from one company to another, you have to learn where those boundaries are, and you get this problem with the role definition really defines the way you engage with a team, the way you collaborate. So that becomes a constraint in making this work. And I put asset managers in there, and apologies to the asset managers. So asset managers are vitally important because now there's new processes that you have to follow, the asset management processes. To be compliant, you have to really understand this stuff. But an asset manager should just be an operations manager that understands how to get the best out of an asset, should learn. So I use that as an example, because project managers, if they're using systems engineering, need to understand it, because it's how you do your job. So what's the value of systems engineering? Why should we even adopt it? Some studies done, Carnegie Mellon University in 2012. It was really defence-centric when they started it in 2012, because they were software and defence and sort of Lockheed Martin and Boeing and those sort of areas where they were going. With the higher amount of systems engineering content in an organisation and capability, what sort of level of performance are we seeing out of their projects? And they saw a massive correlation between the higher the amount of systems engineering applied in the organisation, the higher the performance of it. This is not successful outcomes of projects, this is just higher performing projects. When you actually throw in complexity, so this is project complexity that I looked at, the higher the complexity, the bigger the benefit as well. Going from no systems engineering, had lots and lots of issues, lots of failures, to very good success rates in the with systems engineering applied in the high complexity. So you can see why people gravitate to systems engineering as high complexity, because it does give you that extra bit of value, but it's not the all and end all. This study was redone in 2014. They extended out from defence, they extended away from software, pretty much the same results across their survey. So let's get into the psyche of the project manager. He's got his gates, he knows he's got to start, he's got to get to the end and operate this thing. So he engages his team to deliver the tender specification. The customer said, this is what I want, he picks it up, we get it right, he's got a team to be able to do that. They then prepare the solution based on what they offered in the tender. So they said, we offer this solution, so we're going to develop this solution. And away they go. Usually, at this point, they're locked in because they've said, we offer this equipment, we're going to deliver this equipment, and they lock themselves in and constrain themselves going forward. Get into the design, they develop drawings. Actually, before I get into that, I'll drill down on that. The tender specification from the customer expresses a need. There was a period of time in 2000, 2010, where customers over-expressed their need in very specific terms. They said, I want that piece of equipment to deliver this outcome, and not actually understanding that it wouldn't. But now, definitely now, it's the tender spec is to say, this is what I would like to achieve. It's the performance and functionality I want to get out of this system, around this capability. And people that are supplying tenders or solutions into this go, this is how we think we can deliver this. So it's not a direct alignment. There's no system spec anywhere in there. It's just, this is what I'd like to have. Here's what we think can achieve it. To get to the solution, where you're getting into your concept, and the tender offer that was developed in just a few weeks to throw it into and get across the line, has really now become, in the project manager's eyes, that's the solution, that's what I'm going to deliver, that's the scope that I'm delivering against. So, getting into the design and build, their focus is on accuracy of detail, following the quality management plan, and their focus is around getting through that next gate, got to be accurate, got to dot the I's, cross the T's. They forget about acceptance of the solution, because they're all about getting to the next gate and get through the next gate. And that's not unfair on them, because that's what they've been trained to do, that's what all their standards and processes say to do. Delays, the customer gets it and goes, that's not what I asked for, that's not even close to what I want. Or that's not quite achieving what I'd like, and you do a little bit extra, can you just change this, can you just change that? They get a lot of testing failures because they're realising that the tender spec actually said comply with standard X, but I can't actually test that. And this solution doesn't even have that, so how do I test it? So lots of test failures, and the inevitable outcome, operations start slipping right because they're still testing a lot of stuff they probably don't need to test. And they're getting compromise discussions with the customer. Yes, you can live with this, you don't need to have what you're asked for, you can live with this. And lots of contractual disputes as well. Any project that's failed in that testing phase ends up in lots of contractual disputes. They integrate systems engineering, and I'm not saying it's the holy grail, because systems engineering can be done well, or it can be done pretty averagely. But at least as a minimum, they're trained to get the concept of operations. And if the customer hasn't given it to them, they develop one. So they have to understand, what does this thing need to do and how does it need to operate. They grab the tender spec and they go, right, now I need to drive that down specific to my solution. So how do I actually get that tender spec to match my solution? What parts of that standard are applicable? What parts of that analysis to what I need to actually do. They allocate the requirements specifically to the solution. So then they start using their draws tools, or their requirements traceability tools, and they go that particular requirements allocated to that part of the solution and needs to achieve X as a band of satisfactory outcome. And confirm the testability. If it's not testable, it shouldn't be in there. Go back to the customer and start seeking dispensation or variation. So, customer, I know you had that in your spec originally, but it's not what we can deliver. This is what we can deliver. Here's the requirements that we're willing to sign off on. And so you get some level of, we will be able to test it, we will be able to validate it. And agreement, customer, right up front, concept stage, yes, we're happy, proceed forward, that's what we want. Getting to still develop drawings, hopefully accurately. Still procure long lead time items or equipment, and it's still all about getting the stuff to build the thing. But now you're looking at finalising acceptance. So you're into the design phase, the systems engineer is going, once I've actually designed and built this, how am I going to get a contract? How am I actually going to solve this capability off? What are the things that actually will mean to the customer that they will accept this solution? Build the same, fabricate, assemble, the good stuff. But now the focus is on capability realisation and risk. So the systems engineer is continually thinking, how do I minimise the risk of getting to the next phase? How do I minimise the risk of any of this not working? And how do I maximise the capability? And when you start looking at that, you start to understand systems engineering is about value for money. Maximising the capability at minimum cost, which inevitably is minimum risk. Testing is traceable to the CONOPS. So all the way through that, tracing everything so that you can go, I can actually tell you which tests relate to which part of the operation. And hence why systems engineering was very good software. Use cases grew right down to the requirements set in the software coding so they can then come back up again. Yes, that code delivers that functionality. High levels of test success because you can actually test it. And validation is now for acceptance. So not just validating it because we said we were going to do a bunch of tests. We're validating it to get acceptance. Yes, customer will deliver the functionality and capability that you asked for initially. No delays to operation. The other benefits, logistics are designed in. So as you're going down this path, the systems engineer is going, am I going to maintain it? Am I going to support it? Am I going to look after it? Because I'm responsible to end of life, to retirement, to disposal, to getting rid of this thing. Whereas the project manager was thinking, I just got to get off this contract. I just got to close this project out and move on to the next one. Maintenance alignment is really important. So a project manager will grab the operations manual from a piece of equipment, hand it to the customer, and go, there you go and operate. Systems engineer is actually focused on, have I got the right maintenance? Am I doing the right maintenance at the right time for the right reasons? So the example, PM and SE Divergence, is shows this one's classic software and ICT. The old waterfall model was a project management methodology developed. Was very dependent on systems engineering because they knew this stuff. This is what they brought up on. So the waterfall method is develop your requirements, do your design, implement, verify. You don't get your product at the end until you validate that it's the right product that met the requirements and the solution at the front. But of course, with software getting more complicated, with customers asking for more and more out of what the software can do, they've got longer and longer iteration. And the customers wanted solutions now and didn't want to wait 2 years and find out it wasn't quite that. So along comes Agile, and Agile gradually builds up the functionality, gradually gets you to the end point, but you can see, the customer can see a tangible result there, tangible result there. This is all just paperwork and documents. The outcome, of course, is not the same box, it's not the same software, because as they're going along, the scope's changing, they're coming up with new requirements, and so Agile is now sort of getting a bit of a context or a concept around, yeah, we get success, but it may not be the capability that was originally asked for. The beauty of Agile, though, is it takes the customer on a journey, so they know they're losing scope or they know they're changing scope, and at the end, they have to accept it because they agree all the way along. Every 2 weeks they agree, that's what they do. And of course, the sales pitch from the industry is Agile, at least twice as successful as the old waterfall model. And all the engineers, there's a lot of engineers out here who like the marketing liberty, the numbers don't quite match up to the picture. But the real issue here is what they define as success there is they actually produce the software product at the end, the customer accepted and walk away with. What they're coming up against is a lot of the customers are going, no, actually, I don't just want schedule, cost and quality, I actually want what I asked for. The original capability, the original scope, the original output that I really wanted to achieve on this thing. So we're seeing Agile coming up against some issues and boundaries as well, because if you don't apply systems engineering holistically across the Agile process, a lot of companies do, and they do a really good job, you don't get the output, you don't get the capability, you don't get happy customers. So, systems engineering workshop last year, so you've heard that we're doing a systems engineering workshop this year, so I'll pick up on some of this stuff again this year at the workshop in November. But last year they picked the book up because it came out early last year, and one of the chapters in there is a good case study. I actually worked on this project with the ESN mast up on the top of the bigger mast there. That capability is held up in the book as a really shining example of successful project management systems engineering integration. And it was. And what the book actually calls out is the key tenets. The team called out as well, collaborative work, so they had multiple stakeholders all working together, different organisations, multiple project officers. So in the customer space, they were going across the project office looked after the vessel, the project office looked after the equipment and capability, and software, and all of these teams all work collaboratively to the end goal. It helped that the Chief of Navy really wanted this capability in this project, but they really worked together. Information sharing, there was loads of risk reduction workshops, so they all came together to work out how do we solve this risk to move forward, and rapid and effective decision making, so they had the right people with the right accountability and authority to make the right decisions. But the real crux of this one is that there was no barrier between project management and systems engineering. They worked hand in hand to deliver this. What they don't show you in the book is that that big mast there actually had all the same players in it and did all the groundwork for it. So even though it's not seen as 100% successful, we're going to be over budget and went a bit behind schedule, all of the work done to deliver that bigger mast actually set the groundwork for the SpaceX is the other classic example in the book. SpaceX with Elon Musk stood up an organisation and said, I'm not just going to follow NASA, I'm not going to follow Boeing or Lockheed, I'm going to establish a solution or capability that can actually deliver low-cost space travel. And you can't read that very well, it's very fine print. It's from their 2012 release stuff that had a number of successful rocket flyers into space and recovered them. They had the philosophy of responsibility. So the right people in the right positions make the decisions. So not a case of mixed responsibility, or the project manager responsible for that, the engineering manager responsible for that. One key person that's responsible for the decisions to be made. They had a balance between upfront systems engineering and the downstream testing, the prototyping. So they realised there is a tipping point. You can overdo systems engineering, you can do requirements to death, but there's a balance point at which you go, for my organisation, for what I'm trying to achieve, this is the amount that I need to do to establish the outcome. They learned through experience, so they failed a lot to get to a success. They designed testable, so this is the systems engineering and really coming out. Everything they did was about, we have to be able to test that. We have to know what we're testing to and the acceptable parameters that we're trying to test against. And then they just tested and tested and tested, and they keep testing it. They took the traditional systems engineering lead and said, yeah, that could work, but what we want to do is just take the top level requirement of get to Mars, identify the key design parameters, and then work with those key design parameters so that we can trade stuff off. And their collaboration and integration aspects is really around trading off those parameters to get the right outcome. And all the while making sure that they kept the concepts of being able to verify and validate all the way along, so they got what they wanted at the end. So they're acclaimed at being able to produce space travel at a third the cost of anybody else can at the moment, and it's, they actually advertise how much it costs to get into space. So the first company to do it, the only company that can do it. It's even Boeing and Lockheed that are working together are prepared to advertise how much it costs to launch a rocket. But the key bit, avoid too much organisation, rules and process. It's got to be balanced for what you're trying to achieve. You can't just grab it from one organisation and apply it to another. It's got to be tailored and balanced for what you're trying to achieve. So, achieving enduring integration. How do we actually get the two disciplines and domains to work together to achieve the outcome? And it comes from different perspectives. Because if you're a customer, it's an internal project. You're trying to develop an internal project to meet the end goal, or to deliver better results for your stakeholders or for your shareholders if you have that situation. And so the language always needs to be outcome language. So not, I must control this process because it's the process that's handed down to me. It's what I need to do to deliver the outcome. Every time the systems engineer is talking to a project manager in that environment, the language has to be, why am I doing this? It doesn't translate to how to achieve the outcome we're trying to achieve. The key one is around the untestability. So make sure that anytime you've been asked to design something, the requirements are very clear, unambiguous, you know you can test them, and you have a very high level of confidence that you are going to get an outcome that is a successful outcome. You can actually get the right answer from the testing. Make sure you use your V&V models, verification and validation, to do your risk mitigation. So the reason why we're doing this testing early is to mitigate risk later. And so again, systems engineering, good systems engineering is about risk mitigation, risk management over the whole life cycle journey. Beyond getting the capability into operation, thinking in terms of this is a 20-year, 30-year capability, and beyond, making sure that you're mitigating risk down that stream as well. For a supplier, it changes around slightly, and it's more about acceptance. How are we going to get off contract? How are we going to get acceptance? Because the outcome of your product that you're developing is not for you, it's for the customer. And so the customer's going to own and operate it and use it, and they will have a view of what they need it for and why they will use it. They may not have translated that through the tender spec or any of their contractual documents. So this always has to be about communication with the customer through project management to say, what is it that you actually need, so I can translate it into a requirement that makes sense to me and how I'm going to deliver the product that I'm developing. Always highlight project requirements with risk so that you can get off contract. It's all about getting off contract with your supplier. It's not about designing a gold-plated solution. If it's about that, then don't go to SpaceX, you probably go to NASA. It's really about making sure that you deliver a solution that meets the needs of the customer. And acceptance strategy is key. As a supplier, it's got to be around how am I going to get acceptance of this product. You can stand there as the best engineer in the world and say, I've designed the best product. The customer picks it up and says, how am I going to use it? I don't even like it, I don't want it. Yeah, it's a waste of effort. So, the do's around this. And so in the workshop in November, I'll be going into a little bit more of case studies and some, this is what we tried before, this is how it's successful. But here I really just want to touch on the fundamental thinking that you need to have when you're trying to integrate a team or collaborate to achieve the outcome. And requirements derivation is definitely key. The reason why systems engineering adds so much value is because systems engineers do a great job of requirements. Manage them, deriving them, understanding them, testing them, selling them off. It's not a spec, a functional performance spec. It's taking the functional performance spec, understanding why the customer has asked for that, driving it down to what is the requirement that I need to deliver against, and how am I going to test it, and how am I going to deliver it. Acceptance strategy, as I said before, has to be right up there. It's the next thing on the line. Once you're deriving your requirements, you've got to say, how am I going to do it? How often do I need to test this, and will it fit within my test program, test schedule that the project manager has helped develop? It usually comes to the engineering team to go, how long is it going to take you? And then you tell him it's 3 months, and he says, I've only got a month, and you're trying to look at a program. bring it back to that. What's the bare minimum we need to do to get acceptance? If that's a month and 3 days, align it to your organisation. So what are problems that companies have in defence suffer from this a lot? Take the process from here and apply it here. Yeah, you have to apply that process and you have to be compliant. But it just doesn't work. It's got to be tailored to your organisation, how you're constructed, what the roles and responsibilities are, and also what you're trying to deliver out of that organisation. You can't take a defence bunch of processes and apply it to rolling stock and get a good answer. We'll never get a good answer in rolling stock. Tailor it. Systems engineering was always intended to be tailored. There was always guidance. It was always good practice. Unfortunately, over time, it's become, no, you have to do that gap. You have to pass the systems requirements gap. Quite often you can go, well, no, I don't. The customer's already accepted that product. They don't need to understand the systems requirements. They just want to dive into the next phase of preliminary design. The good systems engineer will go, but there's elements that need to be developed. So they'll take that on the preliminary design review and flesh it out, get a customer agreement. But it's really about tailoring the process to deliver what you're trying to achieve with what you're trying to deliver. Apply it holistically, always step back. And it's easy, especially as engineers, to get sucked into the detail and get lost in the analysis, lost in the study. You keep stepping back and going, what are we trying to deliver as a whole, as an outcome, then it adds some clarity as to what you're doing down the line. I'll just touch on the last one, PM risks there. Project managers will always sit there and go, oh, I've got resource risks and I've got all these other risks. But there's never any context. So a systems engineer can come in and really add a lot of context to why is there a risk? How are we going to manage and measure that risk? And so as risk evolves in companies, and start doing a lot more Monte Carlo analyses to understand schedule independencies. And now that the new 2017 version of project management's come out, you have to. So you have to make sure that all of your risk is aligned to schedule, turn schedule, and so that's a good one for systems engineers. If you're trying to crack that nut, go through the risk register and start putting some context and clarity on the risks. What you shouldn't do, never use compliance language, you will lose a project manager instantly. Have to comply. Okay, I have to do it. Duplicate process. So if project management has a process, dovetail into it. If they don't, go, here's a good system engineering process you can use, and we'll just adapt the language so everybody understands it. Likewise, you go with asset management. I'm starting to lose focus with people going, here's my asset management process, here's my systems engineering process. It's a company process to deliver a product or capability or an outcome. So if you're ending up with multiple processes and people that own these processes, go back and say, let's pull it together. We're one organisation with one outcome. Don't copy others, as I mentioned before. Don't blindly follow standards, and don't embed SE tools in isolation. So systems engineering has been around for a long time. It's all back in the 40s. A lot of tools have developed. Model-based systems engineering is now the catchphrase. These tools are great. Enterprise architecture, they do a really good job of what they're meant to do. They don't just apply them in isolation because they'll just cost money and not add any value. They've got to be used for the purpose that you want to use them for. You have to be able to see the outcome at all inputs, be able to see the outcome and how it's going to deliver your product. Don't ever constrain systems engineering to technical scope. They go, you're a systems engineer and you're dealing with technical, go, but the technical is pointless without the rest of it. So systems engineering, particularly what it was always intended to be, is delivering a whole scope, a whole solution for cost, schedule, quality, and don't protect role discipline boundaries. So they're sitting there going, oh, it's trending in my area. Well, the project manager is saying, no, you're doing my job. Come together and sit down and say, no, we're doing this together. Let's work out who's actually doing it. There's always grey areas of responsibility. Let's work out for tomorrow who's doing it, for next week who's doing it, for the week after. That might change. It might vary between the organisation, it might even vary down through the organisation. So that's pretty much where I wanted to get to. I'll just quickly give it, when you're thinking about why systems engineering and you're going, systems engineers do this, and project managers do that. Classic is systems engineers get relegated to the product. In most organisations I see, they get told, you develop the requirements for the functional performance spec indoors and break it down so that you can get the function, performance, and compliance with standards. But the scope of work has a bunch of requirements in there that directly impact the delivery of that. And so if you don't take the requirements out of the scope of work, to use them either as constraints or as elements to what you're trying to do, then what you end up doing is gold plating the solution. Because the customer has probably said, I want something cheaper than us to get to work tomorrow. And you get a functional performance spec that says, it has to deliver X meters per second and have X quality. And you start deriving a set of requirements that inevitably the project manager can't deliver against. And don't lose sight of the tail end. Systems engineering is life cycle to disposal of that system and that capability of that asset. And even in the disposal, it's about how do we move from the disposal into the new. So don't ever lose sight of the fact that support has a bunch of requirements. And all your functional performance stuff there is meaningless if you can't support it. It's a good way to think, to integrate a whole project. Project manager will be out there going, get out of my scope of work, I'm delivering scope. But what you want to be able to do is go, my functional performance spec is reliant upon understanding the scope of this project is and what my strengths are delivering. And baselines is probably another fundamental. So system or asset baselines, what do you need to manage? You manage just the functional baseline, or what I see is a functional baseline gets managed until the point that you start detailed design and then you forget about it. The functional baseline could evolve over time. So if you're looking at defence at the moment, you've got submarines that are going to be around for 50 years. The third submarine will not be the same as the first submarine. The sixth submarine will be completely different to the first. So those functional baselines are evolving over the life cycle of that capability. You can't think of it just as one submarine baseline that you just want to do. It's got to be evolving with the capability over time. And likewise, your design baseline that most people in systems engineering are familiar with, your technical specs, system schematics, engineering, bills and materials. So you start to get this barrier between, I've done my design, now it's over to procurement and the production teams to worry about it. Engineering has to worry about it all the way through. So whatever part they're going to buy downstream as a manufacturing part or as a supply part is still a system engineering responsibility and engineering in general responsibility. And finally, physical baseline. So what are you actually trying to do with this capability? So how many configurations are you going to manage? So the new generation roller stock I mentioned at the start, they have to now manage two discrete baselines of the product that they never intended to manage in the first instance. And they have to know that one baseline cannot operate on one part of the system. So they've introduced a constraint and complexity they probably didn't want to. But say like they didn't get it right at the start, we've got to manage it going forward. That physical baseline, understanding what the product's for, what capabilities can achieve is critical across the whole. So that's it. Thank you very much for attendance and listening, and open for questions. And keen to see you all in November to get into some nuts and bolts and how you actually practice now.